Hi everyone, welcome to another session. In this session, we will discuss about container, what is containerization, and also we will do comparison between type 1 hypervisor, bare metal, and container host. This session might be a longer session, so because we will try to emphasize on container concept. So that is another important concept for the CISSP exam. Let's get started. So first of all, let us discuss what is containerization. Containerization is a lightweight package of an application and its dependency like libraries, binaries, so it could run reliably in different computing environment. So for example, think of a container as a box containing everything the app needs to run, right? So container share the host kernel, no separate host inside each container. So they are faster and lighter than virtual machines because they do not need a full OS. Example of container technologies: Docker, Podman, Kubernetes. So here you can see this is operating system, and on top of that operating system we have Docker engine, bins, libraries, and on top of that we are running different apps. So 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 containers share the host OS kernel, no separate AS. So on same way as OS, on same operating system, all these apps are running, right? So key difference from VMs, each VM has its own AS. So you can see on this side, on the left side of image, every VM has its own OS, but all containers share host OS. Overhead, uh, higher, each VM has full operating system. Here the overhead is uh, higher because of every single VM has its own operating system. So here, container host, the overhead is lower, only app plus uh, dependencies. Uh, if we talk about startup, uh, this is uh, this is relatively slower, but container is faster. Portability, harder to move, to migrate VMs from one hypervisor to another hypervisor, that is harder to move. But in container, easier to move across environment. Security and use cases, containers still need isolation, process, network, storage. They are great for microservices, splitting an app into smaller parts, CID, CI/CD pipelines, testing and deploying faster. Uh, Cloud environments, especially in cloud environments, scale easily. So the key insight is the containers are not VMs. They share the host kernel, not extra OS. They are faster, easier to move as we discussed, but still need careful security because they share a kernel. So security is something which we need to consider very important for container because they share a same kernel and uh, operating system, right? So key examples, Docker, the most common container platform, uh, Kubernetes, an orchestration tool to manage many container at scale. Uh, it is not itself a container engine but controls them. So Kubernetes is a tool which manage many containers at large scale, right? So container do not have their own OS as we have discussed. I'm emphasizing on this point again and again because that we need to understand the difference between type 1 hypervisor or VMs, that they share the host OS kernel, right? Isolation container use OS level mechanism like C group and namespaces in Linux to keep them separate like VMs but lighter. The concerns are process, network, storage, isolation containers have these challenges just like VMs. So the bottom line is containers lower overhead because no extra operating system needed per app, right? They are perfect for agile, DevOps, and microservices, but security isolation can be tricky, especially because they share the OS kernel, right? So in this diagram, you can, as we have discussed, you can see this comparison shows the difference between type 1 hypervisor and a container host, right? Each VM has its own OS kernel, and we discuss they have more overhead. Containers have single OS kernel, they are faster. So, and containers save resources and start fast, but share the same kernel that we discussed multiple times. This can be a security risk if it is not managed carefully. VMs have better isolation but are heavier. Each has its own OS kernel, right? So core component in container platform Docker Kubernetes, right? So uh, key security concern we discussed isolation, process, network, file system because all containers share the same OS kernel. Supply chain container images can be tempered um, with if pulled from untrusted sources. Runtime security monitoring and controlling container activity during execution. Orchestration security ensuring the orchestrator itself like Kubernetes is securely configured. So the problem is if OS kernel is compromised, then the entire uh, container will be compromised. Uh, so container hosts are cloud-based virtual machines where the container runs. Example, a cloud-based VM running a container engine like a Docker. So Docker is an engine that execute containerized applications. So Kubernetes, most cloud service provides offer a hosted Kubernetes service like Amazon, Azure, Google. So this handles health monitorings of container nodes, maintenance like patching, scaling, auto recovery. You only pay for the agent nodes where your container run. The management cluster Kubernetes control plane is typically managed by CSSP, I mean cloud service provider. Security consideration. So as we have already gone through that, isolation containers, isolation is important. Um, so the bottom line is that cloud container hosts provide flexibility and scalability whenever it is needed or required. Strong container security measures, runtime security, image scanning, trust in the CSP, managed services, control plane, monitoring tools, container level isolation to mitigate risk like data leak or privilege escalation. So, and I think that's it. We have covered the multiple points, important points related to this topic, uh, and so I think that's it. If you have any question or feedback on this topic, kindly share in the comment section. But as I said, container containerization or container is a very important topic for the CISSP exam. Thank you so much for watching this video. If any feedback or question, please share in the feedback section.